Welcome to the first MaDiTraCe project webinar. My name is Ignacio Calleja. I am Senior Advisor for Circular Economy and Recycling at EIT Raw Materials, and I will be the moderator of this, from my point of view, very interesting webinar. Just to let you know that I will not tell you about the MaDiTraCe project because the first speaker, Daniel, will tell you everything in depth and in a very clear way about the MaDiTraCe project. Just to tell you that within this first webinar, we will have a very interesting agenda with speakers from the MaDiTraCe project, so partners from the MaDiTraCe project telling you about what we are doing, what we will do, what will be the main outcomes and results of this project that started just at the beginning of this year. But I think that we also wanted to provide not only the point of view of the MaDiTraCe project and the MaDiTraCe partners, but also different points of view of external stakeholders, okay? External stakeholders not participated in the MaDiTraCe projects that could provide interesting views and interesting opinions about the traceability issue of critical raw materials in Europe just now. In this case, we will have, for example, Fabrice from the JRC. We will have Jacobus from Monolithos, which is a Greece recycling company. And we will have Omar Perego, who will also represent Emily, that's very important industrial association in Europe. So yes, to tell you that we have a very minor change in the agenda because Maria Niever from DG Grow has not been able to join us today. So we will have Fabrice Mathieu from the JRC taking the content of the Maria Niever presentation also from his side. So just now I would like to give a special thanks to Fabrice to be willing to adapt his presentation in a very short time. So also from my side to tell you that if you have any questions for any of the speakers, please include those questions in the chat. The idea is to have, after each presentation, we will allow just a very short question, a very quick question, and then we will compile all the questions for the end of the session. So please, in the question, write your name. Please write the question and write also who the question is for. So no further issue from my side. Yes, to let Daniel to join us. Daniel Monfort is the MaDiTraCe project coordinator. And here you have 20 minutes for your presentation, Daniel. So the floor is yours. Thank you.
Thank you, Ignacio. First question, can you, no, it's always the same issue with that. So I will, sorry, okay. Sorry, up. Can you see my screen?
Yeah, perfect.
It's perfect.
In a presentation
way. Okay.
Yeah, perfect now. Thank you.
So thank you for being today here in this presentation of MaDiTraCe project. It is a Horizon Europe project. We start in January of this year, so we don't have really results of our project. For the instance, it's normal, but of course we have some ideas and we have a background. So I'm Daniel Monfort from French Geological Survey, BIRGM. We are based in Orléans City in the center of France. I'm geologist, but I'm working a lot also in industrial ecology topics. So the name of MaDiTraCe is Material Digital Traceability for Critical Raw Material Certification. And in a few words, the goal of our project is to bring in greater transparency, traceability, and sustainability to raw material supply chains. We have in the scope, it is a sort of umbrella of our project, EU battery regulation, also EU Directive of Corporate Sustainability Due Diligence, and we are, how to say, dealing with many topics that we are speaking every day in newspapers. So raw materials for battery, but not only for battery, also for energy transition, for example, and how to assure a supply for EU material needs in a sustainable or most sustainable as possible way. The partnership of MaDiTraCe project is composed by these logos in this slide. We, Bergiem, we are the coordinators of the project. We have also another geo survey in Finland, GTK. There are universities as Leiden and Ghent University and Mountain University. So universities dealing and working on different topics. We have also companies such as Alfred H. Knight, DMT, Funditech, Spherity, Metsoautotech, LGA. We have also clusters such as Iberian Sustainable Mining Cluster, and we have also an 80 raw materials. Thank you for organizing this webinar. And we have also research institutes like CUA in France. So it is a consortium dealing with many different topics, as I will present you later. It is not only a question of geology or raw material sciences. A little bit larger than that. Is a quite multidisciplinary project because it is a topic quite multidisciplinary by definition. We are 14 partners, 7 countries, around 1 or 11 million euros of funding, 3 years to achieve all our objectives, and we are dealing with 4 critical raw materials. It is a project MaDiTraCe in a very particular context. Raw materials for battery, responsible sourcing, battery passport, critical raw materials act. Every day we can read something new about that. So of course we have the European CRM Act. Fabrice Mathieu from GRC, unfortunately Maria Nieberg, she cannot join the webinar today, but Fabrice will present you the main ideas of some of the main ideas and topics in CRM Act, also the activity that GRC is doing also in raw materials topic. But there is not only the CRM Act, of course we have all the rules and regulation specific to battery. It's here it is the Reuters news from 2 weeks ago. And we have also, we can see also many raw materials diplomacy, let's say, for example, discussions between EU and Chile to work together about lithium supply chain, for example. We have also seen that mining projects are also in the agenda or expected in some countries. So here it is an example in France from a lithium mine, project of lithium mine in the center of France. And of course we have also this map of all the gigafactories expected in Europe. So it is a topic with many things, many people, many projects also working on that. So it is also a little bit challenging for us because there are many on parallel activities. Also many things are being done at European level, at also at national level. The 5 objectives of MaDiTraCe project are these ones. Is the first one is identify gaps in current due diligence practices and assess manufacturing industry needs in respect to compliance with sustainable standards and regulation. The second one is to develop a sort of portfolio of geochemical technological solutions to control or trace the provenance of raw materials in batteries. That will be mostly the presentation of my colleague Anne-Marie later. Third objective is integrate this portfolio of solutions in a certification scheme for critical raw materials supply chains from the mine to the manufactured, and also include, if possible, it is a challenge, recycled products. Objective 4 is integrate technological solutions into a digital product passport, which is also a big trending topic in this moment, battery digital product passport, or in general, digital product passport, which is a passport containing many information of products such as batteries or such as smartphones, etc. And then facilitate that take. Of course, we are a research project, but our product, our results has to be also implemented later. We are working in MaDiTraCe in 4 commodities: cobalt, lithium, and natural graphite, which are mostly in battery and mostly in e-mobility, and rare earth elements, which are mostly needed for permanent magnets, as for example for wind turbines, but also for electric motors. The MaDiTraCe concept of our project, and I think that later Susan, our colleague, will speak a little more about that, but is to ensure the data exchange between the mine and the final product. The final product is associated to a passport, a digital product passport, and we want to ensure that, for example, the raw materials put in the market or contained in my battery respect some responsible mining criteria, let's say. So the goal is how to exchange this data of provenance or conditions of all the raw materials that are integrated in a battery. And also there is a notion of control, and here the portfolio of geochemical technologies, but not only geochemical, also artificial fingerprint. This portfolio is a tool to control or to check if the information that you are delivering is correct. So it is also a challenge for us, MaDiTraCe, because we are putting around the table very different communities. The community of geochemistry, which is working since many years ago on trace the origin of metals, for example, using isotopy, but not only that, with other communities, such as the community of blockchain, for example, which is working in data exchange and IT solutions for that. So the expected impacts of our project are, of course, to improve supply chain data transparency and traceability, as I said, identify and address these gaps in due diligence, set up technological solutions for tracing raw materials flows. So at the end, one battery is a set of different raw materials and different raw materials flows around the world with a very complex supply chain. And for that technology, how to exchange this data, maintaining some confidential data, of course, that's an expected impact of our project. Also to develop comparable criteria, reporting and audit approaches. One of the big expected impact is enable sustainable sourcing of raw materials. We want e-mobility. We know that for e-mobility we need more raw materials, and we expect that these raw materials that we need for batteries are exploited in the best way, as much as possible in a sustainable way. And this information has to be included in the final product passport. And of course, our objective is also to support the implementation of different EU actions dealing with critical raw materials. That's a classic organization of the project. It's not very important for you today. We have a work package, technical work package dealing with intrinsic material fingerprint, and my colleague Anne-Marie will speak a little about that. We have a technological solution work package, certification schemes development, and then classical communication and dissemination work packages. And also we assess needs and gaps in due diligence, and we are also starting to create a stakeholders community for the project, because it is a project with dealing with and working with very different communities. Just a few words about our previous experiences. We are a consortium with experiences in very different fields. For example, in raw materials traceability and trace the provenance of metals, we have geochemistry. That's the goal of the presentation of Anne-Marie from Virgin, an example about lithium. But we have also University of Montat-Leuven. They are working on that. GTK, so our colleagues from Finnish GeoSurvey, they are also working on that, and they have also an ongoing project which is called MaDiTraCe. And we have also the colleagues from Ghent University working on that. There's another topic is artificial fingerprint. That's a very new topic for us, and we want to check this in the project. It concerns to put little particles in some raw materials mix, and if we find these little particles later, that means that you come from this plant, for example. Then we have technology solutions for digital product passport. That's the little presentation that will be done by Suzanne from Spherity. Then we have life cycle assessment and material flow analysis, which are topics also quite important, because, as I said, we want that the battery passport contains also information about the potential environmental footprint also of the obtention of extraction of raw materials, and we have to be aligned also with these criteria. And of course, at the end, sustainable mining standards for responsible mining, and that's the work done mostly by DMT. And Tania will present you the work that they are doing in Seraforin in these topics. So yes, that's all from my side. And now, but we are looking for engaged stakeholders, and we are also very interested to obtain and to have sort of partnership with raw materials providers, because one of the goals of our project, as I said, is to test and to check the provenance and the origins, and to build a database. So any manufacturer, raw material actor in Europe or not in Europe, which is interested, please send an email and we can start to discuss with you. Of course, this collaboration is in a win-win approach. It's good for us, MaDiTraCe, but also has to be interesting and for you if you decide to collaborate with us. And that's all from my side. Thank you for your attention. I don't know if we are good in time or not.
Yeah, Daniel, perfect in time.
Okay.
So even 3 minutes before the timing, okay. So no problem. Perfect. Just checking the chat. I don't see any question for you at this point. So participants, if you have any question for Daniel, just send it through the chat right now. If not, we will move to the next presentation. Thanks, Daniel.
Thank you.
Now we have Fabrice Mathieu from the Joint Research Center of the European Commission. I repeat my special thanks to Fabrice, because in a very short notice, Maria from DigiGrow told us that she will not be able to join, and Fabrice agreed to cover Maria's presentation also from his side. So thank you, Fabrice. The floor is yours. Thank you.
Okay, thank you, Ignacio. Thank you, Daniel, for the kind invitation and for the kind words. I will consider that you can hear me and will continue, otherwise you tell me. So indeed, thank you for the invitation to the European Commission. My name is Fabrice Mathieu. I work at the Joint Research Center in Ispra, Italy. European Commission is GSE is part of the European Commission. I will say a few words about that. Just to jump on what Daniel said, it's a very multidisciplinary approach in the MaDiTraCe project. So just to introduce myself, by training, I'm a mechanical engineer. I did then some specialization in circularity analysis and life cycle assessment analysis or environmental assessment, and actually joined the Commission 12 years ago. And I'm trying my best to support policy with science and technical hints. So that's for myself. On the content of my presentation, I try to stick on the title of the webinar. So I will address very much as much as possible raw materials, but also digital product passport. So probably I will hope to contribute very much to the objective 4 of the MaDiTraCe project, but there are also some links with other objectives. And as mentioned by Ignacio, initially I wanted to just give a science for policy perspective, so the GSC perspective, but because of the absence of Maria, I will also give a policy perspective on the behalf of DG GROW. You can see the disclaimer. I will have an easy job here because on the GROW presentation, I will just tell you what I know, but because I was not involved in the cooking of the Serum Act, I mean, not directly in the kitchen, so I will just be able to answer clarification question, but let's see how when the question come. So I want to first of all present the GSC. The GSC is not such a well-known organization, but so I enjoy this moment. The GSC is a knowledge and science service of the European Commission. We are based in 5 member states. You see here that we are based in Ispra, in the northern side of Italy, on the shore of Lago Maggiore, and that is a nice place that you can see on the picture. And my directorate, called the Sustainable Resource Directorate, has got the vision that you can see here and the mission that you can see. And basically, we work on many topics, but in my unit, we work very strongly on raw materials, including critical materials, circular economy, sustainable development goals, and also life cycle assessment. So that's why I'm giving a talk today. Now, I go into the part which is giving a bit of context of the Serum Act regulation proposal that was proposed earlier this year. The slides are from DG GROW. Thank you to Maria for sharing them with me. And I will just try to convey to you to give a bit of framing of the policy context, what you can find in the Serum Act proposal. So first of all, we all know what are critical materials. We all know that they are important for the EU economy, and that's the EU is strongly dependent from other countries for their supply. And we also know that because of the transitions between digital and low carbon transition, there is an important, significant or incredible growth of CRM demand. And you can see here the numbers on the lithium. These figures are well known, and that's actually coming from the update of the GSC report that was published together with the proposal, the Serum Act, in March. You see here the numbers. Of course, the demand for lithium for batteries in the EU will be multiplied by 21 times by 2050. And this applies to many materials, including also permanent and rare earth elements. So that's the context. Then the Commission has proposed, following the request from the President von der Leyen, it has proposed a European Critical Raw Material Act that contained a communication but also a regulation proposal. And the objective is to ensure a secure and sustainable supply of the critical materials to the Union, because they are absolutely critical to the delivery of the Green Deal, but also of the EU Open Strategic Autonomy strategy. So the 4 pillars of the communication are to strengthen the whole stage of the European critical materials value chain. The objective is to diversify the imports of critical materials so that we can reduce dependencies. We need to develop our monitoring capacity so that we're able also to take the right decision to mitigate risk of disruption. And there is a strong chapter on circularity and sustainability rated in this package. Again, we speak here about critical materials. We all know that critical materials are important because they are suffering of an important supply risk, and they contribute to they are very important for the economy of the EU. But the communication has also identified strategic raw materials for some good reason. That we need a bit of forward-looking approach, and the CRM approach was so far the list of CRM was usually based on back data and data from the past. So we need a bit of strategic thinking, forward-looking. So the commission, the regulation identify strategic raw materials, which are key for the strategic technologies, the twin transition, but also space and defense, and where there is a strong demand in the future, and there are risk of supply breakdown. In the first articles of regulation, there are some benchmark for 2030 and some high-level objective. And you can see here that the high-level objective are written, and they are quite ambitious. The objective is to have 10% of the EU extraction of the consumption of strategic raw materials to be happening in the EU. The EU needs to have also the processing capacity up to 40% of the strategic raw material consumption. And the same for recycling capacity, it has to reach 15% of the consumption. And there is also a need to diversify the supply, and there is a quantified objective of 65%. That should come from should not come from a single third country. The critical materials list has been expanded to 34 raw materials, critical materials. The methodology is still the same, and you see here the list of critical materials, and in bold you see the list of strategic raw materials. Yes, that's it. And now the next steps. The proposal was published in March this year. You can find all the links to the communication, but also the content, the background documents. And now what's going on is that the trilogue, the usual co-legislation discussion has started between Commission, Council, and Parliament. Discussion are happening right now, and the objective would be to adopt that proposal before the next European Parliament election in June 2024. That's it for the proposal. I hope I was complete and correct, but apologize if it's not the case. Now, that was the first part. That was a part on the policy that I humbly passed to you. Now I'd like to go more into the detail and more about the work of the GRC. So the GRC is involved in various analysis, especially for the battery regulation, but also for the vehicle policies, upcoming policies. And I wanted to share with you some thinking about the MaDiTraCe project on the features that should have the digital product passport if you want to be supporting policy. So they are our GRC personal opinions, but of course this is all for discussion. So I will give example mainly, a lot on the battery regulation, because you know that the battery regulation is an ambitious life cycle based proposal, and the GRC is giving some signs for policy analysis and contribution, preparing the second legislation. You know that it's ambitious and potentially game-changing because there are several requirements, innovative, by the way, that are entry market, meaning that if manufacturers of battery don't respect the requirement, in principle, they cannot put on the market. And that concern responsible sourcing, that concern carbon footprint, recycled content, and there are also some features on recycling efficiency, more for recyclers, but that also impact, of course, batteries and battery manufacturers. And there are also some links with second life. And I would like to discuss these 5 aspects, the one in red in the box, in the rest of my talk. And to tell all the story, a lot of these measures, of these provisions, will rely on data, and potentially the product passport will be able to provide this data. So it's important that the MaDiTraCe project deliver something that can support policy. So I'd like to go more in the detail of that and give some features. So the first aspect is about responsible sourcing. Article 48 of the battery regulation mentioned the battery due diligence policies. And in Article 30 of the Serum Act, there is also some provisions on responsible sourcing in the sense of environmentally responsible sourcing, because it's required here to declare some environmental footprint of raw materials. So based on these two requests, so I just want to say that the what we call responsible sourcing or due diligence concern both social but also environmental risks. We all know, unfortunately, the social risk related to, for example, cobalt mining in RDC. So the first feature that I would like to mention, and that when I read a bit the MaDiTraCe presentation, is that it's important to have verifiable data. When you provide data on raw materials, it's important that you have verifiable data. Potentially, I heard that you also want to work on spatially resolved data on raw materials, so that could be a good feature, and that could be also used to verify some policy claims. So that's the first feature, and I'm happy to discuss that. The second feature, but also that's still related to environmental, to responsible sourcing, still about environmental performances. You know that in the carbon footprint, in the battery regulation, the Article 7 is on carbon footprint, and manufacturers will be able to put on the market only if they declare the carbon footprint of the life cycle or even respect some targets. And this life cycle carbon footprint will have to be based on quality assured data that has to comply with a so-called product environmental footprint requirement, and should be combinable. I mean, all the data should be combinable so that we have a life cycle perspective. So if you develop some data on, for example, environmental performance of mining, think about making them, first of all, quality assured, but also combinable with all the downstream LCI data so that it could be used in the calculations. You can here find the links of the rules on the carbon footprint that were developed by my colleagues in my corridor here, and that are supporting the Article 7. So that's again a recommendation on the data that could be in the battery passport. If we go ahead, we go for the stage of circularity. The stage is multiple, as the end of life or start of the life. So starting by the recycled content, the Article 8 is a first of a kind on this respect, and manufacturers have to declare and respect some targets on the content of recycled content for cobalt, lithium, and a few others. If you will have to declare where the material comes from. So I don't know whether you are thinking about also looking at what can come from the recovery of tailings if we consider primary raw materials. But if we speak about the post-consumer secondary raw materials or pre-consumer, I mean, when the materials in the battery, think about declaring separately the recycled content coming from pre-consumer batteries going out from the battery manufacturers because they do not pass the quality control, or the materials that is coming from the post-consumer battery waste, because it could be important in the future for the implementation of Article 8. So that's a kind request that I do if in case MaDiTraCe want to take that. If we go ahead on the circularities, there are some strong recycling efficiency and material recovery level targets in Article 71. And again, that would be very useful if you put data on raw materials in batteries to have for the reporting purpose of recyclers, but also for their cooking, the practice they do on cooking recycling processes. Could be very useful to have a very precise composition of the raw materials in the batteries. So that's again a kind request I'm formulating. And now thinking the fact that the battery allows or encourage second life of batteries, and considering that the second life might imply to change a module or a cell in the battery, probably this declaration of the raw material information should be at the level of the cell or the module, but not only at the pack level, because the pack level might have a second life, and we need to continue to keep this data along the value chain and according to the circularity loops. So that was some hints batteries, it's about e-vehicles, especially motors. Daniel mentioned that it's also part of the scope of the project. We have just published a report on analysis of circularity of rare earth permanent magnets in the context of the vehicle policy. In principle, the Commission will publish a new policy in the course of July. And we have also proposed in this report, and let's see if policymakers select it in the proposal, selected critical metals in vehicles. So we are proposing this requirement on this declaration for neodymium and dysprosium in the motor, in the e-drive motor, but it could also concern the gallium in electronics. So yes, so and very well the battery passport proposal that MaDiTraCe will do can very well capture this feature. And of course, the digital product passport will need to allow the smooth circulation of data along the value chain to be able to, so that the OEM of vehicle can declare this kind of information. Okay, that was it for the battery and the vehicle policy. Now, thinking a bit larger, definitely your battery passport will serve some purpose, the battery regulation purpose, the vehicle policy purpose. Tomorrow they will have a potential recast, and there is also the work on the eco-design for sustainable product regulation that will also cover other products. So one, you have all the passports. The passport will definitely support the policy, the vertical policies. But thinking a bit larger, the sum of all of that can also be useful because it can help to consolidate data on secondary materials. And here, I'm sure that MaDiTraCe will do the link with the Futuram Horizon 2020 project that aims at developing better knowledge and data on secondary materials. It surely will contribute to consolidate data on raw materials, and what we call the end-of-life recycling input rate is very important. That's what we could call the recycled content in the EU economy, but that's an important part of the monitoring and of the calculation of the critical materials. And it could also be helpful for monitoring purposes toward the objective of, in particular, of the Serum Act. And definitely, we need to have that to be able to say that we reach by 2030 the recycling capacity of over 15% for the strategic raw materials. So there are more, a bit thinking on what we do with these individual passports. I'm done. Sorry, I was a bit longer than planned. Just a summary. Ignacio and Daniel, so data on raw materials in digital product passport should be in principle precise because we want to use them to be able to verify some claim, but still flexible because policymakers at the moment are quite creative, and some other provisions from other policy might come. So please keep it flexible, keep the provision flexible. They should be able to circulate fluidly along the value chain from extraction to end of life, including put on the market. They should be traceable and verifiable so that they can be used for policy compliance purposes. And definitely they should also be aggregable in the sense that, we could aggregate the data from different product groups so that we can use them for monitoring purposes. So I thank you again for the chance to reflect a bit on the MaDiTraCe project, and I look forward to discussion. Thanks.
Okay, thank you very much, Fabrice. Really interesting presentation. Let me to check the chat. No, we have no questions at this stage for you. Just to remind to our participants that if you have any question, please include the question in the chat. We will allow for a quick question after each presentation, and then we will compile all the questions at the end of the session to have a discussion with all our speakers. So please, if you have any question, any comment, include the comment in the chat. Thanks again, Fabrice. Now we move to the next speaker. Next speaker is an external stakeholder, not participating in MaDiTraCe, Jakobus Jakomis, CEO of Monolitos. Monolitos is a Greece recycling company. And as I told you, the idea of the webinar is not only to have inputs or presentations or ideas from within the MaDiTraCe consortium, but also to allow external stakeholders to propose or to comment about relevant issues dealing with traceability of critical raw materials. So, Jacobos, thank you for accepting our invitation to be here with us today, and the floor is yours. I don't know whether you can share your screen because we have had some technical problems with Jacobos during the morning, but if you are not able to share your screen, tell me and I will share the presentation for you.
Yes, good morning to all. Unfortunately, it says only presenters can share the screen, not
in
does not
theory
give me
you
access.
should be presented, but anyway, let
Okay.
me
If
to share.
you send
Yeah,
the last.
let me to share my screen.
Okay, in order not to lose
And,
time, I send you the presentation. Okay, my name is Iakos Giakoumis. As Ignacio just told, I'm coming from Greece. Thank you very much. And
okay, can you see the presentation?
Yes.
Perfect.
Okay.
Thank you. Just tell me when I have to move to the next slide.
Okay, and I'm the CEO and founder of Monolithos Catalyst and Recycling Ltd, which is an SME from Greece. By profession, I'm a chemical engineer with a PhD in metallurgy in platinum group metals recycling. Next slide, please. I would like to thank Ignacio and Daniel for the invitation. Just a few things about Monolithos. Monolithos is a production and industrial SME producing automotive catalytic converters and recycling of platinum group metals and different critical raw materials coming out from secondary resources from cars. We are dealing not only with automotive catalysts, but with batteries and permanent magnets and fuel cells. Our research innovation department is running more than 20 European projects in the fields of catalysis, circular economy, and green hydrogen technologies. And we have a very good and established collaboration with most of the big OEMs in automotive sector and universities and research centers. Next slide, please. The company has last year 3 million euro sales turnover with more than 25 employees, and we are located in Athens, Greece. Regarding the scientific achievements, we have 4 European patents and more than 23 peer-reviewed scientific publications, and with 4 PhDs being conducted in our premises. Next slide, please. Okay, this is our main contribution to MaDiTraCe proposal and traceability. So in the company, we are developing a universal recycling project method, which is able to recover the strategic and the critical raw materials from different streams of secondary raw materials coming out of from cars, from end of life, mostly cars, or spare parts of cars. So we have developed this hydrometallurgical process, which is able to process at the same time automotive catalysts, fuel cells, permanent magnets, and the batteries, especially the cobalt containing batteries, and we are able to recover the critical raw materials in order to achieve the goal that just said by the previous speaker about the 15% of the recycling of the consumption of European Union. Next slide, please. This process has been validated from different projects that you see here. Can we have the next slide? Do you hear me? Yes, thank you. And very recently, last week, European Sustainable Week provided an award to our head of research and innovation department, Dr. Anastasia Maria Moscovi, as a women in energy, due to the fact that we have developed and we are very successful in recovering critical and strategic materials from different kind of streams coming from automotive sector. The same came from outside Europe, since we got last year the UK Climatech category award about the same recycling. So how this is coming along with traceability. Next slide, please. The biggest problem in recycling in the European Union coming not from the technology, because more or less the technological barriers are being overcome for recovering critical raw materials. The two barriers that they are existing are, one is the legislation barrier, and the second one, the traceability barrier. And that is very important to your project. So if we are going to an end-of-life car that contains a lot of the strategic and critical raw material that Fabrice showed before, platinum group metals, rare earths, lithium, cobalt, and other materials, what we have seen is that for specific components, the traceability has been implementing in the legislation. So nowadays we can recycle and get back a lot of material in order to reuse it. Two of these components are the lead acid batteries, old batteries that we know in cars that in order to have the ignition, and the tires. In this case, the legislation forces the recyclers and the refiners to state how many lead acid batteries and tires have been are recycling from each car. So they have to report for one lead acid battery and 5 tires, giving back all the numbers, serial numbers and traceable numbers to the authority. So we can trace back from which car is coming and which kind of material has been used. On the other hand, other very important strategic material like catalysts now and batteries and permanent magnets in the future are not in the same category of the legislation, and the recycling rate is measured only by the recycling rate of the weight of the vehicle. So in this case, we say that the recycling of the catalyst is going in the recycling of the scrap metals of the car. So in the process, we are losing the platinum group metals inside that. So only 5% of the catalyst can be traceable right now, and we can know from where the platinum group metals are coming and if they are recycled. Next slide, next slide, please. So what we are proposing and should be done in order to achieve the goal of the 15% recycling of the consumption in Europe in 2030 is that the legislation for the traceability and the recycling of secondary raw materials from cars should be the same for all strategic components. So the legislation that is already in place and the certification about lead acid batteries and tires should be applied the soonest possible to the other very expensive and strategic metal contained in automotive catalysts, which is the platinum group metals, in permanent magnets like neodymium, samarium, and other rare earths, and of course in batteries like lithium and cobalt. So this is the only way in order to the traceability to help the recycling rate and to help to reuse or recover the metals in order to catch the perspective of the and our goals in the European Union. Next slide, please. Of course, since you have a very good project, you have mentioned these aspects about the recycling on the labeling of final projects of final products and the recycling of post consumer products in the transparency area of your project. And it is very important that you by providing the traceability and from the fingerprint, the digital fingerprint of the metals from where it has been started, mined, and processed, then which company or in which car has been deployed, and after that, the recycling of the car, the first provider of the processing should receive back this material in order to reprocess it and have new batteries, permanent magnets, or catalysts. So this is very important to comply all the findings to comply all the good aspects and success stories, success cases in the past of the legislation, certification, traceability, and recycling in order for the original processors of the materials to be able and to be supplied with recycled materials and recycled metals in order to be able to provide new components for the automotive industry without having either to mine them or import them from third countries. Next slide, please. Of course, you know better than me that all these three components, the strategic metals, both the noble metals, the permanent magnets, and the lithium-ion batteries, are going to be in very high demand and in very short, and there will be shortage in the supply in the European Union. So recycling and traceability and the help of traceability in the recycling of this material is very important in order to be able to provide more and more material to the European industry in order to reprocess it and to make new products for the European automotive industry. Thank you very much. I think this is. Thank you very much, and I'm open to your questions.
Okay, thank you, Yakos. As I told you, the idea of the webinar was to have both presentation from partners within the consortium, but also presentations from external stakeholders to have a broader perspective of traceability of critical raw materials. Here we have a question from Michael, DMT. I think it's a question for you, Jacobos. Traceability technologies for raw materials are still being discussed. Which traceability technology for automotive parts do you suggest? Rare earth supply chain traceability is likely to be done via mass balancing.
What I suggest is, for example, for the rare earths, in every electrical motor, in the serial number of the electrical motor, to be defined the weight of the permanent magnets and the rare earths incorporated in this electrical motor, and for the final recycler to report that this kind of material and in this way has been given back either in the recycling industry or to the first producer of the motor in order to be reused and recycled. So we have to comply these two very important aspects: the traceability and the legislation and the certification for having all this material back. Right now, just for your understanding, because the final owner of the car is the owner of the material, most of these materials, they are lost in the chain. So they put all together with the car and they go in the scrap in order to be recycled as scrap material. So we are losing very important strategic and critical raw materials because they are just recycled as aluminum or ferrous components of the car.
Okay, thank you very much, Jacobos. So we move to the next speaker, and this time we have Marie from Virgin. In this case, is we have a presentation from a partner of MaDiTraCe project, talking specifically about fingerprinted technology. Okay, Marie, thank you. The floor is yours.
Okay, thank you, Ignacio. So my name is Anne-Marie de Solti from the French Geological Survey, BRGM, and I am a specialist in metal isotopes to track anthropic pollution and geomaterials. So today I am presenting the material fingerprint technology as a tool for key commodity traceability. One second. Okay, what is the aim of the material fingerprint technology? Develop material fingerprint technology is a way to control and audit the information included in the material passport supporting the certification scheme. As shown previously, in the MaDiTraCe project, we focus on key commodity, lithium, natural graphite, cobalt, and neodymium, mainly relevant for battery and magnet supply chain and strongly linked to automotive industry and wind energy. In the MaDiTraCe project, the partners for the development of the material fingerprint technology are the French Geological Survey BRGM, the Finnish Geological Survey GTK, the CEA, the University of Ghent, and the Mountain University from Austria. There are also companies, AHK, Mezzo2Tech, Spherity, and also GMT. How does the material fingerprint work? This method is used since 30 years in archaeometry, in particular to establish the origin of archaeological artifacts or coins. And the goal is to using measurable and quantifiable material property of ores, such as mineralogical, geochemical, optical, or textural property, to discriminate the raw material sources in terms of deposit type or geographical origin at various scale, from country, region, district, until the individual mines. There are key conditions to develop material print technology. It's necessary to have measurable and quantifiable material properties of ore which differ depending on their genesis. This property should be invariable within the ore deposits. And here in the MaDiTraCe project, we will work until the final products. It's necessary to have a property conservative along the value chain. Moreover, this method is based on a comparison of a sample in question with reference samples of no origin stored in database. In line with the MaDiTraCe project, in line with these principles, in the MaDiTraCe project, we will establish a reference databases for a diversity of worldwide deposit and producer, for cobalt, natural graphite, lithium, and neodymium. We will also retrieve geochemical information from the various material types along the supply chain, from ore until the manufacturer object and included intermediate products. For example, for the lithium, we will analyze spodumene, lithium salt, cathode active materials, and also battery. In the MaDiTraCe project, we will develop a two-tier approach using one side and one line technique, and we will also use laboratory techniques. First, we will use one side and one line technique using fast, robust, low destructive, and cost-effective techniques to control and audit at selected checkpoint of the supply chain the information transmitted in the digital trail. For example, we will test on their system like LIPS or XRF, and we will also use mobile system such as XRF, XRD, and also LIPS. In the case of anomalies are detected by one side and one line MFT techniques, they will trigger other investigation, and we will use laboratory material fingerprint techniques. This including isotope composition measured by MC ICP MS. For example, we showed previously for the lithium supply chain that the lithium isotope composition differs depending on the origin, and the idea will be to check that the isotope signature of battery matches its declared origin. Of course, we will also investigate other methods such as mineralogical, geochemical, optical on textural compositions. Finally, the big multidimensional dataset produced by the two-tier approach, using one side and one line the material fingerprint techniques et laboratory material fingerprint techniques, will be analyzed by a statistical method and machine learning algorithm. And the coupling between material fingerprints techniques and this algorithm will be connected to the digital passport to detect fraud at different stages of the supply chain. Thank you for your attention, and I remain at your disposal for any question. And if you want to provide samples for the MaDiTraCe project, please contact us. Thank you.
Thank you, Anne-Marie. Very interesting presentation from the technical perspective of one of our MaDiTraCe partners. I have a question for you.
Yes.
From Chander. Nice presentation. Is MFP technology is finalized for the MaDiTraCe project? Will be finalized for the MaDiTraCe project? This is the question.
The question is if the material fingerprint will be finalized at the end of the project?
Yeah, this is the question. Yeah.
Okay. We want to have a proof of concept for at least one commodity at the end of the project.
Okay. Thank you, Maria. I hope the question is responded. I have another question for you. Could you tell in more detail what machine learning techniques are used for fingerprint in the origin of lithium?
Okay. I am not specialist of machine learning techniques, but in a Bear RGM, we have a lot of colleagues specialists of machine learning techniques. And in particular, the goal is to use machine learning techniques already used for other projects. For example, used in a water for the water issue. It's already used in a BRGM for other projects. But I am not a specialist. I'm sorry.
Okay, thank you very much, Anne-Marie. So we now move to the next presentation. Thank you, Anne-Marie. And we move to another presentation from a MaDiTraCe project, in this case, DMT. And I would like to say thank you to Tania for her presentation today. And it's also it's very important to know the opinion of the different stakeholders within the value chains of the critical raw materials. And here we will have a very interesting opinion from relevant primary stakeholder in the value chain. So the floor is yours, Tania. Thank you.
Thank you, Ignacio. So I've already shared my screen. My name is Tania Noaz, and I'm from DMT. And I will be talking a little bit about the chain of custody gel requirements, and we'll be looking at it from the certification point of view. So the focus first came onto supply chains when COVID-19 pandemic hit and the mine sites were closing, the production facilities and processing facilities, they were suspending their operations. And not soon after, it was the EU conflict minerals regulation that came into place. And it required the importers, the EU importers of the 3TG, that is the tin, tungsten, tantalum, and gold minerals, to show that they're actually getting their minerals from responsible sources. And that actually brought DRC into focus, that is the Democratic Republic of Congo, as you can see the picture on the left-hand side. And they were actually related with very serious violations of human rights in their supply chain, as well as financing of armed groups, and as well as detrimental impacts on the environment. But somehow, these minerals still make it into our formal supply chains and into our products. Secondly, you can see the picture on the right, the devastating impacts of the Russian attack on Ukraine, and as a result of which there were lots of sanctions being imposed on Russia, but somehow their gold still makes it into the refineries of China and India, and they're not flagged as suspicious minerals, rather they continue to be traded. And it's not only the primary supply chains, it's also the secondary supply chains that come into question. For instance, global refiners also depend upon recycled gold, and recycled gold has actually become an excellent source of money laundering and illicit gold. And who actually really wants to question the word recycled? So that actually makes us want to look more closely into the supply chains. So when we look at a very simple representation of a supply chain at the bottom, it is mainly the downstream players who come under the constant strict grip of the regulatory bodies. And they want to see whether the products that are being made, whether they're responsibly sourced or not. And it's not only the regulatory bodies, there are other stakeholders like the consumers or the customers who want to know what is in their products. So it's not only the pressure from the regulatory bodies and the stakeholders, but also if they look at it from their point of view, they are also prone to operational risk. For instance, maybe there is a social conflict and the entire supply chain is disrupted because of that social conflict in their supply chain, or reputational risk, for instance, if they're associated with any kind of conflict minerals in their products and consumers don't want to buy their products anymore, or some kind of commercial risk. Maybe there is a new niche market for sustainable products and they cannot access that market anymore. So for that reason, the downstream players, what they do is they ask the players who are upstream to them to show provenance, like where is their material coming from, and what kind of processes are going in, what kind of sustainability information or emissions, for instance, what kind of information they can provide. They want more traceability, they want more transparency. And this is exactly pulling on the chain, and the chain of custody is coming in place. So ISO has defined chain of custody as the process by which inputs and outputs and associated information are transferred, monitored, and controlled as it moves down the supply chain. So there are different requirements, for instance, stated in different standards, in different research articles. They're mainly focusing on the four main aspects of the chain of custody requirements. The management system, the control of materials, transfer documents, and an evaluation system. So coming first to the management system, there requires to be a conformity in place, and they need to have a sourcing policy in place to say that, yes, we can actually take up the chain of custody, to have a structure and a responsible person who can actually understand what chain of custody entails and can implement it. So implementation, of course, it brings into maintenance, and the organization needs to see what resources they already have, what kind of resources they actually require in order to maintain the chain of custody. So there are different they have to also know about, they have to maintain the list of different suppliers and subcontractors that they're dealing with, and also provide training to their employees. And if in case there is any changes in the procedures, the processes that they're included, so it must be communicated clearly to the employees so they know about the changes. And of course, the management system, they need to do an internal evaluation that depends, the frequency completely depends upon the management system, if they want to do it on a quarterly basis, for instance, and if there are any corrective mechanisms that they have to do, and they have to document the procedures, and also should have a complaints and feedback handling mechanism put into place. Next come the control of materials. When it comes to transparency and traceability, you need to know how to control the materials, and there are different chain of custody models which are out there to deal with these materials. So for the purpose of this presentation, I will say that For instance, if it's coming from a SARA certified mine, we can say that we can call that mine certified. And if it's not SARA certified, but it is coming from responsible sources, I will call it like non-certified, for instance. So in case of, there are 3 different types of models, as you can see. One is like no mixing allowed, where you do not mix the certified and non-certified materials. And next one is the mixing is allowed, where you're allowed to mix the certified and the non-certified materials. And in case of credit balancing, which is like book and claim, there is no relation between the physical flow of materials and the administrative flow. So this actually has an impact on the different features. For instance, sustainability and traceability will, of course, be really high in case when there is no mixing of materials. Like in case of identity preserved, you actually know where your materials are coming from, which particular mine. But as you go down the table, it becomes almost next to non-existent. But yes, keeping all of these materials separate throughout, having an auditing process, having very stringent requirements and handling processes, it can actually include that the cost can increase. So which is actually really high in case of identity preserved, but as you go down the table, you can see even book and claim, the cost reduces. Next is the transfer documents. So each and every time that the materials are actually transferred from one entity to another, and a transfer document will be there once the transaction is registered. My colleague Susan is going to shed more light on this slide, but nonetheless, transfer documents can contain suppliers information. For instance, you can see in an example down in the picture, suppliers information can have like the name of organization, the location of mine, the contact details, very basic information. And input and output materials information, like how much of materials is coming in, what kind of accounting method they've already used, for instance, transporter or shipper details, processing information, or sustainability information, like any kind of emissions that has been happening in the supply chain. Moving on to the last one, which is the evaluation. So there is a important necessity for having the auditing process to understand that whether the chain of custody system which is in place is actually working or not, whether it is in conformity with the applicable requirements. So that will depend upon the auditing and the frequency. The standard could decide the frequency. Mostly it's annually, which is done, and inside the auditing, which is done by the management, the internal management system, that could be dependent upon how much they want to do, how many times they want to do it. And there are different types of audit, like external audits, internal audits, on-site, off-site. So the type of audit will be actually dependent upon the different types of risks which are identified. And in case of any non-conformities which may arise, corrective actions must be taken proactively, and all of it must be documented. So in conclusion, what I want to say is that there are lots of standards out there, and a quick check across different standards that showed us that most of the standards are commodity specific, or they're lacking the technical aspects which actually needs to be included right now. And there is a lack of harmonization of structure and as well as terminology. That is, even certified materials can be cited as sustainable materials or green materials or conflict-free materials. And there are also the sustainability aspects are kept as optional. So those things, plus the evolving legislations, as you've seen in the previous presentation, there are lots of legislations which are coming out. And with the movement towards green transition, we need to look at more minerals rather than just focusing on 3TG minerals and diamonds, for instance. So we need a standard which is flexible, as Fabrice already said, and something which is scalable as well as adaptable, to show that we can source the products responsibly, as well as, to have a responsible procurement as well. Thank you.
Thank you, Tanya. Very, very interesting presentation, concrete, clear. Thank you very much. Let me to check the chat. No, it seems that we don't have any question for you, Tanya, at this point. So
okay,
if you allow me, thank you. If you allow me, we move to the next presentation. And in this case, this presentation is from Susan Sferity. company. She's also member of the MaDiTraCe consortia, and I think that her presentation is going to complement previous presentation from Tanya, right, Susan? So the floor is yours. Thank you.
Absolutely. Can you hear me and can you see my presentation?
Yeah, both. Perfect.
Wonderful, because I cannot see you anymore or the chat. So bear with me. So yes, thank you, Tanya, for giving this wonderful introduction to what I'm doing. Now we heard a lot of experts on the traceability and the technology, the certification, the material experts. And what we're bringing to the equation is now processing this information about the product, about the raw material, storing it and keeping it available, making it available throughout the supply chain to authorized partners. So we are kind of the technical partner in the MaDiTraCe project, providing a product passport technology. We are also looking at a lot of projects that are happening around the battery passport at the moment. So we are deeply involved with the technology and consortia that are looking into a decentralized solution for the product passport that is demanded by the European Commission. We work with Catena-X, for example, with MOBI. We're looking at the battery passport content guideline and so forth to keep all the technical development that is happening elsewhere also in view and adopted to this important project here, to the MaDiTraCe project. We're kind of bringing in the expertise around the decentralized storage and decentralized setup of such a digital product passport system. Now, what I want to actually focus on is this slide, and I want to lead you through it. It's basically what we're concretely adding to this project. And we've heard about the SARA chain of custody certifications here. We heard of the performance standards. We heard of ionization fingerprint of the raw materials, not only cobalt, but also other materials. We saw the entire supply chain actors here. Now the idea is that the technology and the information about each step in the value chain stays at the originator of the information. And this is also what this supply chain should show here. We start at the very first step here on the left, where we are on the mine side, where several information will be collected either by the mine itself. They give out some information about the product they produce. But as we heard before, we then have laboratories with our researchers that do the ionization fingerprint of that raw material and issue some information and some claims or certificate, as we call them, to that material as well, which also will stay at the mine site. And then we have DMT coming in with auditing or creating the standards for auditing those mine sites after the chain of custody and performance standards or mechanisms. And this information then all stays kind of at the mine sites. The information is going to be issued to them as verifiable information, so a verifiable chain of custody certificate or a verifiable certificate about the ionization a fingerprint of the material, and they keep it kind of at their side. And then kind of the next actor in the supply chain can point to that information. So the trader, for example, can create product information and then point to the raw material, for example, that it's trading, pointing to the ionization, but not holding it or changing the information. The information always stays with the owner holder of this of the material, of the information. We also heard about kind of mass balance information, segregation, ID preservation information. This also kind of is collected along the value chain to allow mass balance accounting, to allow in giving out information about segregation and so forth, what Tanya had previously described. And this is also again kept by the supply chain actor that is equipped with this information. As we can see here, the auditors are giving out the SARA chain of custody certification for each of the actors in the values chain. So everyone has such a verifiable certificate, which can then later be shown to the automotive industry, to the battery manufacturer, or so forth. As well as other certifications. The performance standards, for example, are relevant for the mine and the smelter or refiner. So this information is also issued here by an auditor according to the standards that are being developed in this project, which can also be made accessible then to the downstream supply chain, to the battery manufacturer, for example, to then later on refer to that information to verify it, and then can show the compliance of the complete supply chain. So in principle, this is kind of the part that we are concretely are going to build. What do we need for that? First of all, of course, we need the decentralized technology parts. This is the wallet parts here that you can see at every actor. So every actor will have a tool, a wallet with which they can issue information which is verifiable, and can hold the certificates, as you can see here in the wallet, but can also verify those certificates and this information from others. That's kind of the functionality that we are providing. And for the concrete project, of course, the involved certificates and credential types, as we have seen, are the SARA 4-in-1, chain of custody and performance standard certificates, which Tanya has also introduced. We have some industry vocabulary that we need to collect during the project. So, what is typical information about mass balance accounting, the segregation information, and so forth. Also the ionization information. How do the key value pairs look like? How is it understandable for everyone? We need to define the semantics around it and so forth. We have additional industry vocabulary about, product information, density, quality, and so forth. Maybe product certifications itself. And then we all have to connect that to the battery passport, where the vocabulary is already defined, and from which we will then point to information that we produce during this project. So this should all then in the end work together. So from the battery passport, you can link to information that we have collected and created in the supply chain. And what our activities are in this project are, as I said, defining the vocabulary, so the key value pairs for the STERA standard, for the audit reports, but also for the different semantics that you just saw in the other vocabularies, the vocabulary for the fingerprinting, and so forth, what I just showed. Then we have to define access rules, so who may access which data in the value chain, who can access the audit reports, in which role, the fingerprint information, and so forth. In the automotive industry, for example, this is one up, one down. We have to check if that holds through this project, through the ecosystem that we work in here as well. And then, of course, we have to define, how does the verifiable certificate actually looks like technically? What file format does it have? What signature algorithms are we using? And so forth, and then implement that into the wallets that every actor will get to, as I said, issue material information or company information, and to hold and verify it. And set up also the decentralized storage for those certificates for each actor. And then make it all interoperable, as I said, with a focus that is also interoperable with the activities that happen around the battery passport, and to make sure that we can directly use it for the battery passport, which becomes mandatory soon for batteries on the market in Europe. I think it's 2027 now. Yeah, so that's what we bring to the project. And please, yeah, stay in touch or get connected in case you have questions. You can scan in this code and then you end up at my LinkedIn profile where you can connect and we can easily exchange ideas or whatever you need after this webinar. Thank you.
Thank you very much, Susan. Interesting presentation. Let me to check the chat. Yeah, but it seems that there are no questions from the participants to you at this point. So if you allow me, we will move to the next presentation. And we have started with a presentation from an external stakeholder in this webinar. Then we have moved to several presentations from MaDiTraCe partners. And now we move again, the last but not the least, presentation also from an external stakeholder, okay? To know a little bit more about the expectations, about the opinions of those external stakeholders when we talk about traceability of critical raw materials. And in this case, we have Omar Perego and Nuncia Bernardo representing RISE SE, but also representing Emery, what I think that all of you know about this European initiative dealing with materials for energy. So Omar, the floor is yours. Thank you.
Okay, thank you, Ignacio. Thank you, everybody, to invite me and Nuncia in this webinar. That it is really interesting. All these topics that are covered are really critical and important for the raw material sector. And so I would like to give you a perspective and requirements from the industry point of view in these few slides that I will present here. Nuncia is my colleague. With her, we are really strongly involved in the critical raw material topics, supporting our institution in defining the industry needs and in defining the sustainable supply of critical raw material for our industry, but also for the European industry in general. First of all, I would like to give you a brief introduction of my company, RSC, that is a research center, but is also a joint stock company, because the final SPA means that we are also a sort of industrial company, because we are really strictly connected with the industry, but our main activities are about research. We are working on materials, so in producing advanced material. We are working on technology, producing prototype. We are working on energy efficiency with our studies. We are focusing also in distribution and transmission activities, from the planification, operation, control, digitalization, and so on. And we are finally working for the final uses in all our research activities. Here, I would like to focus on the activities that we are conducting about the critical raw material. And the work was started in 2019 with our research funds coming from the government. Ricerca di Sistema is called. We are focusing on the energy storage, but at the moment we are enlarging to all the energy transition technologies, covering both the supply of raw material with our studies on exploration and mining studies, but also experimental activities of refining and characterization. We are looking at the recycling, and we are looking also as the substitution of critical raw material with non-critical raw material in our advanced activities on producing anode and cathodes of batteries, but also other materials in our energy technology fields. Just to have also an highlight about our connection with the industry, we are following many national, European, and international initiatives. Here, just a overview of what concerns batteries, among them batteries and also grid systems. We are following the work of energy clusters at the regional and national level. We are working with the platform, the European Technology and Innovation Platform, such as Batteries Europe and EthicsNet. And also we're following the work of the partnership, But4EU, CHEP partnership. We are connected and supporting the institution and public bodies. We are following also other initiatives, and all these initiatives represented in this slide are industry driven, and we have also industrial partners in our research activities. I just want to have a special focus on EMIRI, the Association on Energy Material, the initiative on energy material industry and research initiative, and that is dealing with advanced material development. And the last activity of EMIRI is focused on the creation of a new partnership that is AMI 2030, that is looking at all the value chain of the advanced materials, starting from the sustainable supply and finishing on the recycling, sustainable recycling of material. So it is a transversal partnership that could be really important for the work of MaDiTraCe. So I suggest you to focus on also on this initiative. Topic of critical raw material, that is the really most important topic at the European level and at industry level, because all these new regulation and other documents, starting from batteries till other energy technology and other technologies, are dealing with the raw material, starting from the Critical Raw Material Act, but in a sort of industry perspective, because we have also the Net Zero Industry Act and the European Ships Act that are dealing with critical raw material and have obligation of sustainability connected with critical raw material. So industry is looking very well at this topic. Our work in supporting the institution is speculative work of other expert groups that are following in their national level the work about the critical raw materials. In Italy, but I think in all of the Europe, we are looking at the whole value chain of critical raw materials. So mining, sustainable mining, eco-design of product, and also sustainable urban mining. The collection of this information are enabling the industry to define their needs in terms both of supply, but also of demand. So the focus of the working group one that is coordinated by RSC and Confindustria, that is an organization that are supporting the industry needs in these different topics. One of the most important topic is critical raw material. We are looking at the gaps from demand and supply. We are looking at different point of view, critical raw material, product, and sector. We have to give a proposal to our institution of the sustainable supply from extraction, recovery, purchase. First of all, obtaining input from other working groups, but also identifying and analyzing best practices in terms of strategic act in each company we are interviewing. We are focusing on energy transition, but we are expanding our initiative to other sectors. The main goal will be in future the definition of national strategy on critical raw material. I think that is the same aim of each member state that is participating to this European initiative. Here we have also an interest not only at the local level, but at the extra EU level. So there's an involvement of the Foreign Affairs Ministry in this initiative to create international partnership outside Europe. The work is in progress. We are making auditing to the big player. They are much more influent in the market, and they probably have strategic plans on critical raw material. We are involving also small medium enterprise in other ways, but we saw, and this is the critical point, we saw that the engagement of company is still weak. The topic is not well considered, much more because in the short-term vision of the companies, they do not perceive a criticality. So we need an awareness campaign already implemented, because we have already involved media, conference events are already speaking about critical raw material, but conferences are for experts often. So we have to involve mass media. Television is missing. There's already an involvement of political. I'm talking about Italy, but I'm talking about Europe. Italian ministers are already at the forefront of this issue, but also all the member states are fronting this issue. Critical Raw Material Act can be an incentive for attracting the interest of industry, because there are obligations such as the audits. And we are activating territorial bodies, so we are involving clusters, for example, to comment the Critical Raw Material Act proposal at regional, national, and transnational level, because there's a partnership of clusters that are speaking among them. And we were starting with the energy transition, but these cluster partnership are involved with other clusters. Mobility, mechanics, digitalization, medical, and so on. And we are also involving the association and consortia with a special focus on recycling, that is an European asset. And going deeper in this analysis, we are suggesting specific topics of sustainable supply. For example, the geothermal fluid mining, just to involve a company, not only mining company, but a company that are also involved in geothermal sector. They could find a way to valorize the geothermal fluids in another way. Going deeper to the critical material asset, just 2 slides, and I will finish the presentation. We work with the industry to specific article of the critical raw material asset, And we had different reactions, some positive, some negative. For example, the facilitating offtake agreement create some critical points from the industry that would like to be access to a free negotiation of their purchasing, even if there are already some work in progress in the European Raw Material Alliance in the production of this platform for investment that could help the industry and small medium enterprise in their purchasing.
Sorry, Omar, 2 minutes, okay? 2
yes,
minutes.
2 slides, 2 minutes, perfect. Audit has created some problem from company, but it could be an incentive to create a strategy. The joint purchase is an opportunity, and we want to involve in this purchasing also the small medium enterprise. And finally, the environmental footprint declaration is a clear declaration that traceability can help enterprises to preserve transparency in their supply chain. There's also an introduction of new critical raw materials, a proposal introduction of critical raw materials in the list because the industry finds strategic assets on this material that are not formalized by the European Commission. Just for the conclusion, and the conclusion are questions for MaDiTraCe. Traceability, at which level you are working on traceability and who is the beneficiary? Because you can trace the extraction, the production of raw material, but you can trace also the life history of a product from manufacturing to remanufacturing, reuse, recycling, and so on. And what is the level of information availability? Industry, public authorities, policymakers, or also the citizens. So the transparency is the topic here. And about the digital product passport, it must provide probably information about the 3 dimensions of sustainability. So environmental, that include the energy, carbon footprint, economical sector and social sector. And the reference standards of mining, urban mining, and design must include the product acceptability results. You have to fix the results to define these standards. So we suggest to cover the whole value chain, but probably is already in your mind. Which advantages for industry in implementing these 2 features, traceability and digital product passport, into a company strategy of critical raw material supply? I suggest that these tools must be easily accessible, usable, in a word, on hand. So what can achieve MaDiTraCe for industry? I was looking at the 5 objectives and for standard and regulation, traceability and transparency, certification, digital product passport, and update to stakeholder. I'm looking at virtuous purposes. So I will follow this work of MaDiTraCe, and I'm really happy to be invited here to present the activities of RSC and EMIRI in this sector. Thank you for your attention.
Thank you, Omar. So let me to check the chat. No, we don't have specific questions for you. So yeah, we have reached the end of the webinar. We have some time for questions. If you have any, please include those questions in the chat. I think that we have one comment from Daniel. Daniel, you can switch on your camera and microphone.
Yes, thank you.
Yeah.
Yeah, it's a common question. It's for Omar, but also global. I think that we shown today that there are many initiatives, many projects, alliance, industrial alliance, research projects, regulation, of course, at EU level, but also international level, national level, even regional level. A single project like here MaDiTraCe, but other projects also cannot cannot save the world, let's say. I think that we need maybe the very naive comment, but I think that we need a sort of global place to share what we are doing. Of course, battery supply chain is very complex, and battery topic covers many topics. Here, raw material traceability is only a part of the topic of battery, of course. But I think that in some cases it's a really big mess, I think, and it is maybe I expect that maybe one day it will be more less share to share developments and have a common overview of that, because it's really and I'm only speaking about batteries, but if we speak about digital product passport for other products like vehicles, etc. That's also another topic. So yeah, it's not really a question, it's a comment.
Yeah, yes, from my side, Daniel, if you allow me, I agree with you. I think that just now, if we check only from the research and innovation side in Europe, when we talk about Europe, so we have many projects going in the same way. Horizon 2020, Horizon Europe, LIFE, Interreg, projects funded within the EIT and the KICS framework. We also have national projects, we have regional projects. So yeah, I think that maybe it could be interesting to try to have a clustering process for all these traceability focused projects in Europe. I think it could be, my opinion is that it would be really useful. Yeah. Okay, do we have any further questions, comments from the participants? Anything you want to include in the chat? Yeah, we have one question for Anne-Marie. And can the MFP methodology could be used to assess the potential for reuse, remanufacture, or recycling?
Yes, we in the MaDiTraCe project we will try, and it's possible, I think, to keep the isotope signature during the recycling, but it's necessary to try, and it's a goal of the MaDiTraCe project.
Thank you, Anne-Marie. Any further question? Any further comment from the participants? Last chance. Okay, if we don't have any further questions, if we don't have any further comments, I would like to close the webinar today. I would like to firstly thank all the participants. Thank you to all of you for your interest in MaDiTraCe project. Thank you for your interest in this webinar. We will keep you updated about the MaDiTraCe achievements. We will share the presentations, and we will share the recorded webinar with all of you. And now I would also like to invite Daniel for final words as MaDiTraCe project coordinator. Daniel, anything from your side?
No, just thank you to you, Ignacio, for preparing this webinar. That I think is the most important. Of course, as you have seen, we are in the first 6 months of the project, so we are only ideas, objectives, targets, and some experience on previous projects. I expect that in future webinars we can share with you some new works and new results of our project. So yeah, we keep in the loop, and yeah, see you in next webinars or in conference or in real life. Yeah, it is a little world.
Okay, thank you, Daniel. Yeah, so thank you to all the speakers. Thank you to all the participants. This is just the first MaDiTraCe webinar. So more webinars coming in the future from this project. So I hope to see you all on those webinars too. Thank you very much and have a good day. Bye-bye. Thank you.
Thank you.
Bye-bye.
Thank you. Bye-bye.
Bye.